Hello everyone! In this video, we're going to go over every single primitive object that you can find in Cinema 4D. Please make sure that you're not just watching the video, but also following along with Cinema Open and also changing the properties and settings yourself. A primitive object is a type of parametric object, which means that it has parameters or attributes. This means that it can be altered within the attribute manager, and you can just consistently change it without any fear of permanence, which means you can always bring it back to the default. You can find the primitives menu right here in the cube icon. If you click and leave your left mouse click pressed, you will see that you can find every single one from the cube all the way to the empty polygon. Wherever you hover your mouse over, that is the one that you will be choosing, and then just letting go of your click will bring that object out. As you can see here, it comes out of my viewport and it comes out of my object manager. I'm just quickly going to delete this to show you what we're going to do since we're going to talk about all of them. So I'm going to click and leave this press, and instead of every single time coming in here and selecting another one, I'm going to undock this menu. So if I hover over here on the top, what that does is it just brings the menu out. I can move it anywhere I want so that it's a little bit easier for me to just click through them and take a bunch of them out. All right, so I'm going to put it right here so that it's not in the middle, and we are going to start with the cube. Each of your primitive objects, you will see a basic tab where you can see the name and the visibility and other settings here. So this is just basic information of your primitive object. You have the coordinates of your object, which is where in space they are. So here's the position of it in space, the rotation of it in space, and then how much space it is occupying, so the scale of it. Your object tab, which is where all your properties will be for the specific object. Some of the other primitives also have other tabs, but in the case of the cube, the last one is the Phong, which these are connected to the Phong tag directly, which is this thing found right here. And what this does is that it gives us a smooth appearance. So this picture here shows on the left side what it would look without the Phong tag, and here what it would look with it. The Phong tag is automatically put on every single object, and unless you have a specific reason to take it off, you should not change it or take it off. Mostly we're going to be working with the object tab, and then for some other options we have the slice and the caps tab. We already did the cube in class, so we've gone over this, but I will go over it again since this will be a comprehensive guide. So for the cube, we have a 3D shape that has a size in X, a size in Y, and a size in Z. Starting off with our size in X, that is our left and right, meaning the width of our cube. There's multiple ways that I can change this. First would be by clicking and dragging. Holding my left click, if I click and drag towards the right, I am increasing it. Whereas if I click and drag towards the left, I am decreasing it. This is done without letting go of the mouse. What I am changing here is the size in X, meaning the width of this cube. Another way to change it is that I can just type in a number, so 500 for example, and it will turn that cube into a 500 centimeter wide cube. Quick little interjection. I want to show you here why this is a 500 centimeter wide cube. So you see that the axis is right at the center. That is at 0, 0, 0. This means that to the left, this cube goes out to negative 250. And then to the right, it goes out to 250. So you add those two and you get the full size to be 500. Notice my grid space in here says that it is 50 centimeters. That means that each of these grid spaces is 50. So we do 50, 100, 150, 200, 250, and so on and so forth. Same thing with Y here, that would be up and down. So that is the height of my cube. And then here in Z, that would be the depth of my cube. One last way to change it is you can go here to this little dot that you see that's highlighted, click and drag, and you will see that in the attributes manager, you see the difference. So that is the width, the height, and the depth of your object. I'm going to bring these all back. Okay, next we have the segments. In order for us to see the segments, we need to be able to see where one segment ends and another one begins. So to do this, we're going to change the display of our object. So if you go up here to display and you click on garage shading, parentheses lines, That means that I'm going to see the edges of each of my big segments. So the cube is made up of 6 squares. 1, 2, 3, 4, 5, and 6. However, you can increase the segments by going here. These are the segments in X, so that's the width, in Y, so that's the height, and in Z, so that's the depth. I can increase it here, and now I have more segments. These are going to be useful later on because we can do things such as grab the individual segments and interact with them separately. They are also useful for things like deformers, which we will cover next week. Then we have something called separate surfaces. This will separate your cube so that later on, when we break apart the components of the cube, each of the 6 sides comes out separately, such as this. The last thing for the cube is we have fillet. If you click on fillet, it will round your edges. I'm going to take off my garage shading lines for a second so that you can see without fillet and then with fillet. In the fillet radius and the fillet subdivision, you can determine how much those edges are rounded. So again, I'll turn on my garage shading line so that you can see what's happening here. And you see that the radius is 3 centimeters. What that means is that from this edge to this edge, there are 3 centimeters. And what the fillet subdivision means at 3 is that you have 1, 2, and 3 segments. So you split that in 3 segments. If I were to increase my radius, you can see now there's more space in between those segments. You still have 3, 1, 2, and 3. I'm going to do a quick render preview so that you can see that. And if you increase the subdivisions, then the fillet will be smoother. So the more subdivisions you have, the smoother your fillet will be. There is a thing as having too many. For example, with a fillet of 3 centimeters, you probably don't need 9 subdivisions. 3 is usually more than enough. Next, let's go down this line. We have the plane. The plane is a flat piece of geometry. This means that it does not have 3 dimensions. Instead, it just has width and height, which in this case is the length in X and the length in Z. So if you change the width, you are changing the way that it is going from left to right. And if you change the height, you are changing the way that it is going from up to down if it is laying flat. And then we have the segments. Be aware that the reason that we can see them is because we have garage shading lines already on. Otherwise, they would look like this, which is the regular garage shading. That's the default shading in Cinema 4D, and you can't really see the segments while that shading is on. Here are the segments. So how many of these little squares there are that subdivide this object. So you can have less or you can have more. All of these little squares are your polygons. They are the building blocks of your 3D shapes. By putting polygons together is how you get a 3D shape. So by having more segments, you add more polygons, and by having less segments, you reduce the amount of polygons that you have. You also have the orientation. So by default, this comes out as plus Y, meaning that this is facing the positive of Y. But if you change this to, let's say, plus X, now you can see that the object is facing the positive of X, which is to the side, plus Z, and then plus Y again. That is all there is to your plane. Now we have the polygon, and this primitive polygon object is a demonstration of what the polygon would be, which again, like I mentioned, is the building blocks of your full 3D shapes. So I don't want to skip ahead too much and talk too in depth about polygons, but a few things that I do want you to know is that your polygon primitive comes out as a quad, which means there's 4 points and 4 edges that make up the face of it. There's not too many properties to it. You have your width and your height. You also have your segments, which means how many other polygons you're splitting this polygon into. You can also change it to be a triangle, which means that there will be 3 points that will be connected by 3 lines that make up the face of it. And lastly, you also have orientation, so you can change which plane your polygon is laying on. Next, we have the capsule. For the capsule, we have a few different properties. Here we have the radius, which is how big the rounding of the capsule is. I'm going to turn on my display again so you can see that. You have the height, which is how tall this is. Notice that if I were to switch the orientation on my capsule to +X and then I change the height, now the height is changing left and right because the orientation, I am telling it to face left and right. Same thing if I did +Z. The height is how tall it is. It is not directly connected to whether it's going up and down in Y. Next, we have the height segments, and those are the segments in between these caps, which are the round parts here, the parts that are being affected by the radius. So these guys right here. You have your height segments, and you can see that in between those caps, you start to get more segments, meaning more geometry, more things that you can further deform later on. And then you have your cap segments, which are again what's being affected by the radius. So you can increase them and decrease them. And again, this is just more information and more geometry that will make things smoother. So for example, you see here that I have my radius of 38, and if I only have 3 cap segments and I were to do a little render preview, you can see that this looks very sharp. But if I increase my cap segments, I get a much rounder shape. This is very similar to adding more subdivisions to your fillet. If you want a smooth rounding, then you should have more subdivisions so that in the 38 centimeters that I am making this edge go to this edge, there are enough polygons to smoothly connect them. The last thing that you have is your rotation segments. So that is how many segments are going vertically to make this a rounded object. So if I increase it, it gets rounder, and if I decrease it, it gets less round. In the capsule, we also have the slice tab, which allows you to cut this capsule in half. So if you click on slice, now you can see that we have only half of this capsule, and you can select how it's going to be split. Right now it's going from 0 to 180, but you can make it from 0 to another degree. And here you also have regular grid, which just splits how these points are connected to one another. So there would be points right here in all of these edges, and they are naturally connected. But if you check on regular grid, now they connect with mostly quads, which are these quads here that are still split by triangles because of the way that this shape is. But this is better for modeling, and we will discuss that much later. Next, we have the figure. The figure is very simple. It has the height, which would be very helpful if you had to make things to real scale. So for example, if you didn't know the exact dimensions of something, but you knew how tall a person is, then you can use this as a reference for how big your object would have to be. And you have your segments, which again is just more geometry or less geometry. You see here with only 4 segments, each of this have very little information, just a bunch of big segments on there. And if you increase it, it gets rounder. The oil tank. The oil tank has a bunch of options, but they're very similar to the capsule. So we have our radius, which is how big that oil tank would be. Our height, which is how tall it's going to be. Our height segments, which is how many of these edges are in between your caps. Our cap height, meaning how rounded this top portion will be. And then with that, you have the segments, which smooths out the jagged edges here. Lastly, we have the rotation segments, which is how much geometry is going to be alongside the vertical of this object, whether it is very smooth or very sharp. Lastly, we also have the orientation here. In the oil tank, we also have the option of slicing it and of having a regular grid or not. Next is the platonic. In the platonic, you can change the radius of it, so how big it is, and it will increase every single direction at once. You can change how many segments it has. So you can see that as I'm adding segments, the big segments are being subdivided. That means that they're being split. So instead of 1, now this is being split into 4. So 1, 2, 3, 4. And the last thing here is the type. So there's a bunch of different types for your platonic. By default, it's set to icosa, which is for the icosahedron, but there's quite a few options. You have the tetra, the hexa, the octa, the dodeca, and bucky. So a lot of different types for the same parametric object. Next, we have the torus. In the object tab, we can change the radius, so how big that torus is. The segments, which is how many edges are going to be in between, and that means how smooth that ring will be. You can change the pipe radius, which is how thick that radius is. And the segments, which are going to be your segments going vertically. You also have your orientation, and we also here have a slice tab that if you click on it, you can cut this in half, or in less or more than half, as well as regular grid. Next, we have the backdrop. The backdrop is pretty simple to use. It is a great primitive so that when you render, you don't have to render to Cinema's default black void. Instead, you can have like a realistic photography studio backdrop. So here you have your width of the backdrop, your height, the depth, the extension of it, which is how much is coming out on the front. And this is different than the height, which is just the top. And then the rounding of it, which is here in the middle, how it meets and how much that is rounding. You also have a few other settings, such as the tilt, the drop, and the overhang. Here you can also change the subdivisions. In angle, you change how many subdivisions are in that rounding. And then in length, you change how many subdivisions are in the backdrop itself. The bigger the number, the bigger the squares are, and the more jagged edges you will get. The smaller the number, the smaller each square, so there's more information and more for your computer to render, so it will look smoother. But do know there is such a thing as having too many subdivisions, because each of these little squares, each of the polygons, is something that your computer has to individually calculate. The UVs down here deals with how the material will be applied on your object, and because we don't have any of them, then we don't have to worry about this. Going back up, we have the cylinder. In the cylinder, we have the radius, meaning how big it is going to be as a circle. We have the height segments, and the rotation segments. Again, the less segments you have, the more blocky your shape will look. The more you have, the smoother it will look, but there is such a thing as having too many. So if your shape looks good at a certain amount of rotation segments, in this case, 37 looks good for me, I do not have to increase that. Do note how black this shape got. This is because, one, we're looking at the lines. If we weren't looking at it, we wouldn't be able to see this. But here, that just means that our geometry is very, very dense. This isn't good because this means that our computer is trying to calculate every single one of these individual rectangles. We have the orientation. We also have the slice tab here. Something new that the cylinder has is a caps menu, and what this determines is these top and bottom portions of the object. So by default, the caps are on. If I check it off, you see that now we can see through the object, but if it's checked on, then it is now a closed volume. If I increase the segments, you will see that now those top and bottom portions will have more geometry in between them. So more edges, more polygons, and more points. Here in the caps menu, we also have the option to fillet a cylinder, which means these are the natural edges of that cylinder. If I check on fillet, that rounds out those edges. And same thing here with the segments. You can have more to smooth out that rounding. And you can increase the radius to make it bigger or smaller. Now the disc. The disc is a flat circle, so there's no thickness to this object. And we have the inner radius, which by default is set to 0, but if you increase it, this becomes more of a ring. The outer radius, which is how big it is. The disc segments, which is how many edges are going to get added. And then the rotation segments, which is how many edges are going to get added along the rotation of it to make it more round or less round. We also have the orientation of your disc. The disc also has a slice tab, so we can slice it and change the degree in which it is being sliced. Next, we have the sphere. The sphere has your radius, so how big that sphere is. And your segments, which is how many segments are going to be applied throughout the whole sphere. Again, the less amount of segments, the more sharp and jagged these will look. The more segments, the rounder that sphere will be. In the sphere, we also have a type. So we can change from standard, which is this type of sphere, to a hemisphere, which is half of the sphere, a tetrahedron, which is a sphere that has the polygon split all into triangles, the hexahedron, which is a sphere that has the polygon split all into quads, the octahedron, which also has triangles, and the icosahedron. The last option that we have is render perfect, and what this does is that when you send it out to render, even if you have a sphere that doesn't have enough segments, such as this one that has these sharp edges, if you check it on, you will get a render that makes it look like a perfect sphere. The only trick here is that this does not work for Redshift, which is the renderer that we're currently on. So if I were to go and switch this from Redshift to my standard and then click on render perfect, you see that I didn't change any other settings. I just clicked on render perfect. Next, we have the cone. For the cone, we have the top radius, which by default is set to 0, meaning it meets up here at a point, but we can increase this. We also have the bottom radius, the height segments, meaning how many edges will be going up and down, and the rotation segments, meaning how many edges are going to be going left and right. Here we also have our orientation. This is actually the perfect object to demonstrate orientation with, because the top radius will always be pointing to whichever orientation you pick. So by default it's plus y, meaning it's going in the positive of y. If I set it to minus y, it's going in the negative of y, plus x, minus x, plus z, minus z. We also have caps in our cone, which again by default are checked on, which is why we aren't able to see through it. But if I check it off, now I don't have that cap. You have the cap segments. And here you have two separate cap options for your top and your bottom. Because my top is at 0 right now, this isn't going to affect it. But if my top wasn't at 0, you can see here that the top is a fillet option for the top and the bottom. Here you have your radius. So that's going to be the radius that it is going into the cap. Your height, meaning how much is going to go into the side of your cone. And then your segments, meaning how many edges are going to be added here. And lastly, we also have the slice option. Next, we have the landscape. The landscape has quite a bit of different properties to it. So here are the size, that's X, Y, and Z. So left and right, up and down, and the depth, which is backwards and forwards. You also have your segments in the width and in the depth. If you reduce them, you will see that you lose a lot of the detail that's in the landscape, whereas if you increase them, then you gain back all that detail. That is because the more information, the more polygons that you have, the smoother your geometry will connect to one another. You also have your rough furrows. Here I want to introduce you to Cinema 4D's documentation because in every single tool and object that we use, there are going to be a lot of settings. I don't know every single one of them, so it is always a good idea to know that you can access the documentation by simply right-clicking on anything and going to Show Help. This is currently being cut out of my screen, but if I clicked on Show Help, you can see here, I get the max on documentation. And here it tells me what rough furrows and fine furrows are. So fine furrows would be showing you how craggy the landscape is. And craggy means like how rocky your landscape is. Low results are gentle hills, while high values are rough mountains. So here we can play with how rough it is or how fine it is. And you can see the difference here in your landscape. You also have the scale. The sea level is the height of the sea. So the further the value, the further landscape slits into the sea. Whereas the plateau level is the reverse of sea level. So it gets cut off from the top. We also have our orientation here. And we have the option multifractal, which if you disable this option, Cinema 4D will use a different algorithm for generating the landscape. You also have seed here, which is a randomizer for the type of landscape that you will get. Each number will give you a different style and look to the landscape, but taking all these settings into consideration. And border set sea level is whether you have these edges here stay smooth. As you can see, every change we're making is only happening sort of in the middle of this landscape. But if I check this off, now everything will happen to everything all at once. The last option here is spherical, which turns our landscape into a sphere. Next is the pyramid. The pyramid has your size in X, size in Y, and size in Z, as well as your segments that are split in triangles, and its orientation. Next, we have the tube, which is similar to the disc, but it actually has thickness going up and down, as opposed to the disc here that you can see. I can make it look like the tube, but it's just a flat piece of geometry instead of having thickness going up and down, meaning having more of these polygons that are making up the 3D shape, whereas this disc is a 2D shape. In the tube, we have our outer radius, so how big it is going out on this edge, our inner radius, our rotation segments, which again, the less amount of rotation segments you have, the sharper your shape will be. The more you have, the more smooth the rotation of it will be. Our cap segments. Remember that your caps are the top and bottom. You can think of them as lids that cover and make your 3D object into a closed volume. Our height. So we can technically turn our tube into a disc by decreasing the height to 0. And then our height segments, plus our orientation. The tube also has the fillet option, so the rounding of the edges. And we have the slice menu. Keep in mind that you can add the slice menu to this main menu. Instead of switching the tabs, you can just press shift and click on slice. And now we have our object properties and our slice properties down here. Or you can always just click on it once and it'll take us to our slice properties. Next, we have the Bezier. The Bezier gives us control points that we have to be in our point mode to interact with, which is this mode right here. You select these control points that it is giving you, and then using your object's axis, you want to click and drag in any of the directions in order to create a Bezier curve. For the Bezier, we have our subdivisions. Your subdivisions X are going left and right, so how smooth it is from left to right. Your subdivisions Y are going up and down. Your grid points are how many of these points up here you have so that you can interact with. The more you have, the more you can interact with. And lastly, we have close X and close Y, which you can see here in the documentation, that are used for closing the surface in X and in Y for making tubular objects. So if I close this here and then I move this point. Lastly, we have our empty polygon. And this is just an empty object that can be used to later on add geometry to, or to use as a grouping method. One last one that I want to show you is actually not found in your primitives menu at all. It is found right underneath it. So that is the text menu. If you see here, you have two different texts. If I were to select the one that just says text, this is also a primitive object, but it works for text. So you can write in anything you want here in the text spline options. And you have your depth, which is how thick this text will be. Your subdivisions. So how many edges are going to get added going back and forth here. The type of font that you want. How it's being aligned. By default, it is left aligned, meaning the axis can be found on its left side, but you can align it to the middle or to the right. The height, meaning how big it is. The horizontal spacing, which is talking about the kerning. And then the vertical spacing, that if I were to have another word down here, it would be talking about the leading. You also have a few more options here that I'll let you play around with. In the text, you also have a bunch of different tabs that you can experiment with, such as the caps tab, which you sort of already know what it does. It just works slightly differently in the text, so I do encourage you to go in there and play around with it. And that is it for this video. I hope you enjoyed it. I hope that you learned a lot, and I will see you guys next time.